All right, so in your notes, we are on 8.4. It starts out with information on triangles, okay? So first, just some basics on triangles. You should already know a lot of this. Triangles, it's a polygon with three sides. So a three-sided polygon. The height of a triangle is very similar to the idea of the height of a parallelogram. Remember, it wasn't always a side length. It created a right angle with the base. Same idea here. It's the perpendicular segment from the vertex to a line containing the opposite side. So you'll see in the pictures what it's going to look like. But the base is always a side length. The height is not necessarily a side length. Sometimes it is if you're dealing with a right triangle. A lot of times it's not. And then the base is just the other side. So here are the different ways these could look. So you could have a right triangle. These are the easiest ones, I think, because the base and the height are both sides.
Don't move on, baby.
I'm actually going to get it all up on the board. Then I'm going to pause for the catching up process. The other situation, and this is like in acute triangles is where you would see this. You have the base. It's one of the side lengths. And then the height is from the opposite vertex, and then it just makes a right angle with the base. So you would use this number and this number to find the area, okay? So there are two side lengths that you would not even use. And then if it's an obtuse triangle, so see how this one opens way up, like a really open hinge? The height is actually going to be outside of the triangle. Just remember, the height is the one that makes the right angle with the base. So here it's not even really touching the base. But in order to make a right angle with the base, we have to use some information outside of the triangle. That's why it's the dashed line, because it's not really part of the figure, but it is a measurement you need in order to find the area. So here is the area formula. So you need that base, you need that height. It's the base times the height divided by 2. A lot of times you'll see it written like this, 1/2 base times height. You don't really put that. 1/2 base times height. Same idea as when we were doing the rhombus with the 1/2 times the diagonal times the diagonal. You can multiply the two lengths, then divide by 2. You can divide one of them by 2, then multiply it by the other one. You can type in 1/2 times 1 times the other one. There's a lot of different ways to do this calculation. I would just pick a way that makes most sense to you. But you can multiply them together. Divide by 2 is how it's written here, or multiply by 1/2 is how it's written here. So when I'm looking at this, what's the base? 8. What's the height? 5. So I want to do 5 times 8 and divide that number by 2. Or if in your head you want to divide one of them by 2 and then multiply it by the other one, that'll work too. Either way, anyone know what you're going to get? 20. And we still do, since we're talking about area, the little squared after the unit. So this is 20 square feet. So number 2, we're looking at an obtuse triangle. So you can see that the height is actually not part of the triangle. It's not inside the triangle, but it's still located in our diagram, so that's good. But we have 1/2 times what? Bless you.
15 times.
Good. 1/2 times 15 times 16, or the way it's written in the notes is 15 times 16, and then divide that number by 2.
120.
Very good. Questions? Number 3, the base and height are both sides of our triangle. That's great news. What am I going to do? Yeah, I'm going to multiply those. I'm going to divide that by 2. So 72 divided by 2 is 36 square inches.
I need 80 cents.
80 cents. It's so specific.
Yeah.
I'm so confused.
All right, number 4. It was 72 divided by 2, so 36. All right. Uh-oh. I want the area in. I know. You just get all that complaining out of the way.
Wait,
One foot is just 12 inches. I said it was gonna be easy.
All right, so I want the area in terms of inches. So my base is fine, but my height is not. How many inches are in 1 foot? 12.
Could you solve it? It's 3 feet. Convert the number at the end.
So the question was, can we convert them both to feet and then later convert it back to inches? You could. I would not do that. Because it's more likely to make an error when you're doing that many calculations. All right.
I could go to that.
This is not how we do. Okay. So we already said that this was 12 inches, right?
Yeah.
Okay. So how am I going to find the area?
Multiply.
Okay. What is 12 times 36 divided by 2? What?
192.
So 192 is the final answer? Very good. Okay, back that up a little bit. I was given false information. I know. All right, so the area is 216. Sorry about that. I should have caught that, but I didn't. This next one, they're both in centimeters, and it's not telling me to do anything different, so I'm just going to roll with it. How am I going to find the area? 10 times 16, divide that by 2. So that's 160 divided by 2, which is 80. This next one, once again, we're back to just 1 unit. It's not telling us to change it, so just go with it. How am I going to find the area? Very good. So 16 times 12 is 192. Divide that by 2. We get 96 square feet for our area. Do you have any questions so far?
Nope.
All right, let's transition to the material that's a little bit harder. So now we're kind of going in reverse. You're given the area and one of the dimensions, and you have to find the other one. Hey, Tappy, knock it off. All right, so how do I find area normally?
Divide. Multiply.
Multiply, then divide, right?
Yeah.
You're both right. So normally I do this formula. And normally the A is the variable that I'm looking for, and I have the B and the H. In this case, I have the A, I have the base, I don't have the H. So fill in everything that you know. Now, does anyone know how we would solve an equation like this? Yes.
Times 2 by 50.
Yeah, we can multiply both sides by 2, and that gets rid of that denominator. I'll show you an alternate method in just a second. So we are going to divide both sides by 20, and I get a height of 5 feet. Now, if from here you wanted to do it a little bit differently, we were talking earlier about how you could multiply one of the dimensions by a half and then just multiply it by the other one. You could still do that here. If you just wanted to do this part, you could have 50 equals 10h. And do you see how you still get the h is 5? I don't really care how you solve it. As long as what you're doing is mathematically correct and you're getting the right answer, either method is fine with me. All right, we have another one where we're given the area, we're given the base, we're looking for the height. Turn your watch off, obviously. Thank you. All right, what am I going to do?
No, you don't.
No, you got solve H.
Solve for H. So we're going to start that same equation. What goes in for A? 39. What goes in for B? 13.
Multiply.
Yeah, I'm going to multiply. This one, I would say, I would definitely just handle the 2 because I don't want to work with decimals if I don't have to. Multiply both sides by 2. Get rid of that 2. So I get 78 equals 13H. Then what?
H equals 6.
Divide by 13, and H does, in fact, equal 6.
Inches.
No squared. This is just a length. The area was squared. Questions? All right.
Are you on this call?
Last example of the week.
Yeah.
Yeah. That wasn't a joke.
Oh.
That was real life.
Oh.
This is the last example in our notes this week.
Kosher's pickle.
Let's continue.
I would love to continue. Okay, what's my area formula? A equals, well, A is 12. So area equals the base times the height. I'm taking A out. I'm putting a 12 in. B is B, right? What's going in for H?
B.
H.
Oh, H.
B.
Yeah, you can't be looking for both B and H. You'll never find them. You need to put 3 in for the height. B stays B. And then divide that whole thing by 2.
Could you switch those numbers around?
Can I switch which numbers around? Yeah, I mean, honestly, if you put it in for B and you were supposed to have H, I mean, you'll still get the right answer. You'll have the wrong variable, but...
Will that work for any of them?
Any of them with multiplication. Since multiplication is commutative, it doesn't really matter which order. All right, what do I do now?
Times the thing by 2.
Multiply by 2, so we're going to have 24 equals 3B. B equals 8. Very good.
20 feet.
Okay, so here's how the rest of the week's going to go. I'm going to give you your homework. I told you, this is not that... I mean, I think this goes right along with what we've been doing. If you've been keeping up till now, this shouldn't be that challenging of a lesson. You have a homework assignment tonight, okay? You're going to do that. You're going to come back tomorrow. I'm going to give you a review. I'm going to give you a small bonus activity. I'm going to spend most of the hour meeting with each of you and checking all the work you did while I was gone and all the work we've done this week, okay? So if I've been counting correctly, I think you should have like 6 things to show. Yeah, okay?
I'm gonna do them all today.
So try to find all the work from this week. We had a worksheet Monday, a worksheet Tuesday, a worksheet Wednesday. I'm about to give you one right now. And you had 2 reviews last week with the sub, okay? That's what's going down tomorrow.